Okay, so my screen is visible to you. Can you answer me or just can you just write? Vijaya Lakshmi. Okay, can you reply to me, please? Because I need to start the class. So, am I audible and is my screen visible to you? Okay, so I'm just starting the class. In case you have any issue, you can ask me. So, hello everyone, and this is week 6 of probability and statistics problem solving session. And I'm Kamran Shah from IIT Mandi. Right now, I'm a PhD scholar here in statistics, and the course is running by the instructor, Professor Sumesh Kumar, IIT Kharagpur. So, this class is basically depending on the questions of joint probability distribution. How do we deal with joint distribution? That means if x and y we have two variable, or maybe after a time we will handle this multiple variable. So if we have two variables, then how can we work on that? So there is possibility that two variables are independent, but there is also a possibility that two variables are dependent one. So when they are dependent, so if there is something happening in one variable, then the changes will happen in other variable too. So now we can have different type of variables, sorry, different type of distribution, and x and y can follow different type of distribution. So it may be both discrete and continuous, and then both continuous. So generally, what we take is that both are continuous and both are discrete. So a general example is that uh, in the time where we see that our weight is like is it good or according to our height or not. So that time also we use this joint distribution. So joint distribution. And then there can be like other examples too, like your like heart rate. So if you run, your heart rate will change. If you just stay in one place, your heart rate will be constant kind of thing. So that is also depending. So if you are running or if you are walking, so with your speed, your heart rate is also dependent. So there can be so many examples in real life of joint distribution, so that one is changing, another one is changing, so that time we use joint distribution. Now if you go on theoretical basis, so if the x and y are discrete, x and y are discrete variables, then what you have is that the x is equal to xi, y is equal to yi, and then we write it as this probability at pxy xi, comma, y. And now since this is a probability, so this will always be greater than or equal to 0, and its summation will always be equal to 1, because this is probability axiom, right? Now if we want to find the marginal, So now if we want to find the marginal distribution of x or y, that how x is just changing by itself and y is changing by itself, then this we can write at px at xi is equal to summation yj belongs to y, and then this will be pxy xi yj. So we see that how xi is changing depending on y, and then we do its whole summation, then we get the marginal of x. Similarly, we can find the marginal of y also. Now the third case is that we have uh, this is known as marginal marginal density function, and marginal PMF, you can also say marginal probability, because this is discrete, so sorry, this is mass function or density, so marginal function. And if we want to find now conditional probability mass function of x, then how do we say that if x, we want to find the conditional PMF of x, then there will be dependency of x given y is equal to some yj, or y is equal to some y greater than or equal to yj, or y less than or equal to yj. So that will depend on the question. So let's just see, given y is equal to yj, so that will be px given y is equal to yj xi. So here this one is what? This one is marginal PMF of y. So that will be marginal PMF of y, and the point, sorry, and the point given here is yj. So marginal PMF of y at point yj, and then we want to find px at xi. So that will be pxy given xi yj, because that will be intersection in the above, that will be intersection. Okay, so this is all we have regarding the discrete one. Now if we want to find, now if we want to find all these things when, so for x, if conditional PMF of x given y is equal to yj is this, so for y, that will be opposite one, so it will be pxy xi yj divided by px xi. Okay, let me just write my email here. In case something happened, like my meeting got disconnected, then one of you please send me the mail, because that happened last. Okay, so in case I left the meeting or some like internet disconnection, you just send me the mail. Is it okay? Okay, I'm considered. Okay, thank you. So now the next one is that when we these all things was when x and y are discrete. So now we have, let's say x and y, we have continuous. So the in continuous case, what happens is that we you have x and y both are continuous. So you will have, rather than joint PMF, we will have joint PDF. Okay. So fxy. Now that PDF we write it as fxy at x and y. So you can write it just fxy. Simple. Fx. That's also you can write. So since this one is PDF, so it will always be greater than or equal to 1. And and when we do its summation as infinity to infinity, this one is for x, this one is for y, so according to the question we can change its limits. And this one will be fxy dx dy, and this one will be is equal to 1. So if we do the integration over the whole range of x and over the whole range of y, then it will be 1. And this one is just if b belongs to r squared, then what happens is that bxy belongs to b. This one will be equal to fxy b dx dy. So b is nothing but a range. So let's just say you have this and you have this region. Okay, so this one is that what, this one is a region b which is belonging to r square. Similar, like when you have this just x and we say this region belongs to let's say -1 to 3. Okay, so what we say is that it's uh, Px x belongs to -1 to 3 will be what, -1 to 3 fxy. Sorry, fx it is range only on x. So when it is the range on x and y both, so it will belongs to obviously r squared. So if region, if we are taking any region from r squared and then we want to find its probability, then it will be this, and then we do the integration over that region, so we can separate x and y, and then we do fxy dx. So this is uh, so what happens. And so next you have is that marginal period of x. Marginal period of x. So marginal period of x means we want to find this fx. So fx will be -infinity to infinity fxy dy. Always remember, when we find the fxx, then it will be over the integration over the dy range. Okay, and similarly when we want to find fyy, then it will be -infinity to infinity or whatsoever is the range of y, then we can have -infinity to infinity fxy dx. Okay, so this one is marginal, and then we have conditional. Okay, so for conditional is that what, fx given y is equal to y, so it will be fxy x y, and below we have marginal of y. So this way you can find this marginal and conditional one. So now we can start with the questions. So this one is, you can see that given here is that xy is bivariate discrete rectangular. If you have any question, you can ask. Okay. So now what is given here is that suppose that xy is bivariate discrete random variable such that 0.12 occur with a probability 1 by 4, 1 3 occur with 1 by 2, 2 3 and 3 1 occur with 1 by 8. So the remaining one which are not given, we are considering it as 0. So now we want to find the calculate y is equal to 2 given x is equal to 1. So in this type of questions where you have discrete random variable, to find the marginal ones, what we do is that we make this table. So for the discrete one, we can make the table. We can take the points 1, 2, 3, and 1, 2, 3 here. So this way we start. So here we can take x is equal to 1, 2, 3. Here we can take y is equal to 1, y is equal to 2, y is equal to 3. And then, so firstly, we will see what are the points given. So x, y, 1, 2. Okay, so x is 1 and y is 2. That means here. And it is given with the probability 1 by 4. Next one is that 1 comma 3. So 1 comma 3 with the probability 1 by 2. Next one is 2 3. So 2 3 will be here. Its probability is 1 by 8. And then 3 1. 3 1 probability 1 by 8. So others are 0. Now you need to check whether it is alright or not. So marginal of x, okay, fx. So its sum needs to be equal to 1. So this one, marginal of x is what? Summation over y. So summation over y when x is equal to 1, summation over y will be the marginal of x. So if we take summation over y when x is equal to 1, it will give the marginal of x, that means fx at 1. Okay. Similarly, we will have marginal of x fx2 and then marginal of x at point 3. So here will be the marginal of y. Here we will have the marginals of x. So now what it will be? It is 1 by 4 plus 1 by 2. So 1 by 4 plus 1 by 2. It will be 4, sorry, 2 plus 1, 3 by 4. This will be 3 by 4, this will be 1 by 8, this will be 1 by 8. Okay, now here this is 1 by 8, this is 1 by 4, and this is 1 by 2 plus 1 by 8 will be 4 plus 1, 5, 5 by 8. Now this summation, as this is fy and this is whole of fx, this summation need to be equal to 1. So you just check, this is 1 by 8, 1 by 8 will be 1 by 4 plus 3 by 4, this is 1. Now here it is 5 by 8 plus 1 by 8, 6 by 8, that means 3 by 4 plus 1 by 4, this one. So it is right. So this is 1. So now this table is whole representation of how x and y are behaving with each other. Okay. So this shows, this one shows that it is like valid PMF. Now we want to find the calculate y is equal to 2 when x is equal to 1. So x is equal to 1 is what? Here 3 by 4. Okay, and now y is equal to 2 given x is equal to 1. So this one is y is equal to 2 intersection with x is equal to 1. So if you want to find y is equal to 2 given x is equal to 1, this will be nothing but by is equal to 2 intersection x is equal to 1 given x is equal to 1. Okay. So mm, below we have x is equal to 1 as 3 by 4, and above y is equal to 2 intersection x is equal to 1 will be 1 by 4. So overall it will be 1 by, so A will be this. Any questions, any confusion? So next question what we have is that ax is equal to 1, sorry, ax plus 1, x comma y uh, greater than 0 and x plus y is less than 1. So this is the region we have where it is this function is defined basically. Okay. So now what we know is that x plus y less than 1. So I told you before I think, but the best way to show this region in the plot is this and this. Okay. So if you have any number here, just put it here, and then these are the intercepts. So these are the intercepts of x and y. So 1 and 1. Okay. Just make this line. And what is given here is that x plus y less than 1. So this is less than 1. So this one will be the region 1 and 1. So this is the region of uh, where the joint density function is defined. Now we want to find firstly a. So how do we find? It is known that fxy, if we do the integration over the ranges of x and y completely, then it needs to be equal to 1. So the formula we have is that minus infinity to infinity minus infinity to infinity fxy dx dy is equal to 1. Okay. So now firstly we have ax plus 1. So no variable y is not here. So we can take firstly y range. We can just do the integration over y and then we can do x range. So do you know the double integration? Do you have any idea of double integration? How do we find the ranges of double integration? Like, how do we find the ranges of x and y separately? Anybody? I'll not ask how to do that. Just I just want to know that do you have you done double integration before? Okay, okay, okay. So otherwise, those who have not done it ever, let me tell you. So if now let's say I want the ranges of y here and ranges of x here. I will show it to you how we can do by y and x and then x and y both. And then we have ax plus 1 here, fxy, and then dx dy. So if we integrate it over the whole range given of x and y, it will be 1. Okay. Now to do the double integration for x, it will be the range. Just see this plot. So this one is 0, this one is 1. So we just say x is from 0 to 1. Okay. So outside will be variableless. Outside range will not contain the variable. So x is from 0 to 1 and y is from, if you see the plot from here, so this one is y is equal to 0 and this one is what, x plus y. This line is just x plus y is equal to 1. So y is equal to 1 minus x. So if you are doing the integration, outside limit will be 0 to 1 and the inside one will be y is equal to, here from the base it is 0 and the above one is 1 minus x. Now similarly, if you want to do the integration firstly for the x and then second for the y, then what will happen is that we can take y from 0 to 1, this one 0 to 1, 0 to 1, and the x will be from this one to this one. Sorry, this one to this one. So x is equal to 0, and the above portion of x will equal to 1 minus 1. So this one will be 1 minus 1. Then you will have this, sorry, here you will have dy dx, because firstly we are doing the integration by y. So here we will have dx dy. So you can do in any way, you will always get the same answer. Okay, until and unless these are continuous. So this needs to be a reminder that this should be continuous. Now we can do the integration. So firstly we are doing with y. So this is constant. So a y, just consider it as b dy. So b dy is what? By just. So it will be x ranging from 0 to 1, ax plus 1, y, limits of y will be 0 to 1 minus x dx is equal to 1. Okay. So now range 1 minus x, and in times 0 it will be 0. Add just one page. So it will be x from 0 to 1, ax plus 1, 1 minus x dx is equal to 1. So now we can just multiply it and solve it. So it will be x from 0 to 1. It will be ax plus 1 minus ax square minus x dx is equal to 1. Okay. So we can do the integration x and x term together. So it will be x square upon 2 a minus 1 minus ax cube upon 3 plus x. So for when x, so x dx will be x square upon 2, x square will be x cube upon 3, and for 1 this is constant, it will be x. So ranges from 0 to 1 will be 1. So what do we have? We have 1 by 2 a minus 1 minus a upon 3, and then plus 1 is equal to 1. So this will be cancelled out. So you will have a minus a by 2 minus a by 3. A by 3 is equal to 1 by 2. So that one will be 3a minus 2a. So it will be a by 6 is equal to 1 by half. A by 6 is equal to 1 by half. So a is equal to 3 will be the answer. So now we know fxy is equal to 3x plus 1. Xy is equal to 3x plus 1, 0. When x comma y greater than 0, x plus y less than 1 else. Now we want to find the probability when y less than x. So probability when y less than x. Okay. So the region we had is this, where the PDF is defined, and now we want to find the probability when y is less than x. So this is the line of y is equal to x. This is the line of y is equal to x, and this is the region when y is less than x. You can take just any point if you are a little bit confused. So this is x is what somewhere like 1 by 2, and then y is very less here. So this is the region where y is less than x. So we want to find the probability when y is x. That means we want to find the probability of this region. So how to do that? If you take x from here up to here, then this lower region, this is the y and this is y. But after this, the y range is changing. So what we can do is that we can just separate this one. Okay. And then we can find this point where the change is happening. So this is 1, this is 1, this is 0. So the change is happening at which point where these two lines are intersecting. So now we can solve this equation. This is y is equal to x plus y is equal to 1, and y is equal to x. Okay. So when y is equal to x, this one will be what? 2x plus is equal to 1, x is equal to half, and then y is also half. So this is the point 1 by 2 and 1 by 2. So up to 0 to half, when x is in 0 to half, y limit is from y is 0, and then y here is y is equal to x. So y is equal to x. And then we have here 3x plus 1 dy dx. Now the second region we have x is from 1 by 2 to 1, and then y is firstly here 0, and then next one is y is 1 minus x. 3x plus 1 dy dx. Any confusion in this? So next is that just to solve this. So 3x plus 1 is again what? Constant. So it will be 3x plus 1 y. X is from 0 to half, and then its ranges will be y. For the y, it is y is equal to 0 to x dx plus x is from half to 1, and then it will be 3x plus 1 y. Y is from 0 to 1 minus x, and then dx. So now we can just put the value 0 to half. This one will be 3x plus 1, and then y is 0, that means 0, so on the upper range dx plus x is equal to half to 1, and then 3x plus 1, this one will be 1 minus x dx. So we will have 3x plus 1, we can just do 3x square, so it will be 3x cube by 3 plus x square upon 2, range from 0 to half, and then it will be I think 3 x minus 3x plus 1, so 3x. Okay, just do it separately. So 3x square upon 2 plus plus 1, so 1 will be x, and then minus minus 3x square, so minus 3x cubed upon 3, and then minus x will be minus x square upon 2. Okay, and then its ranges will be half to 1. So now all you need to do is that put the values so that you can do the, and then answer will be at last 5 by 8. If you have any issue in this question, you can just ask. So now you have this question. Uh, Here we have again x and y are two discrete random variable, and we want to find the variance of x. So variance of x we can find by expectation of x and then expectation of x square. So for the expectation of x, what is expectation of x? It is x f x, summation x of x. So firstly we want to find the marginals of x, and then marginals of yeah, I think just marginals of x are needed, not y. So this one is fx, okay, marginals of x. So this one is when x is equal to 0, that f x at x. So fx at 0 will be 3, 2, 1, 1. So 3 plus 2, 5, and then 6, and 7, 8. Okay. Here it will be 3 plus 2, 5, 6, 7. 7, 8. And then here we will have 5, 3, 8, 8, 2, 10, and then 4, 14. So this total is 28a. So the summation is equal to 1, right? So a will be what? 1 upon 20. Now this one is marginal. So you have marginal at x is equal to 0 at 1 by 4, 1 by 4, and this one will be, sorry, 1 by 2. Okay. So expectation of x is summation x fx. So when x is equal to 0, it will be simple, 0, 1 by 4 plus 1 times 1 by 4 plus 2 times 1 by 2. So it will be 1 by 4 plus 1. So sorry, this one will be 5 by 4. Now next we want to find the expectation of x square. So x square will be what? 0, and then 1 square, and then 2 square. So it will be 1 by 4 plus 2 square times 1 by 2. So it will be nothing but 1 by 4 plus 2. 1 by 4 plus 2, so it will be 2, 4, 8 plus 1. I think it will be 9 by 4. Okay. So variance of x is equal to 9 by 4 minus 25 by 16. So that one will be 16. 9 times 4, 36. 36 minus 25 will be 11, I think. So 11 by 16. will be 0.6875. So this will be the recipe. So next question what we have is that we have expectation of y given x is equal to x. So that is firstly continuous random variable, and this is expectation of y given x is equal to x means we will use here the marginal one. So x is equal to x, we will find x is equal to x for the marginal fx, and then we will do the expectation of y. So it will be y and do margin of f1. So firstly, we want to find fx, which will be what? So for x, what we do is that we take the limit of y and we do the integration with respect to y. So this one is 0 to root x, okay, 6xy dy. So this one will be what? Dy respect. So this is constant, y will be y square upon 2, 0 to root x. So in the time of 0 it is 0, in the time of root x it will be basically x. So 6x square upon 2 will be what? 3x square. Okay. So now uh, to find expectation of y given x is equal to x, what we need to find? F of y given x is equal to x. So f of y given x is equal to x is what? Fxy divided by fx. So this one is 6xy divided by 3x square. So it will be basically 2y upon x, right? Now to find the expectation of y given x is equal to x will be, now we are doing with y. So we will have the limits of y dy. So it will be 0 root x, and then it will be 2y upon x, it will be dy. Sorry, y into, because expectation of y generally what we have is that y fy dy. So if you have y given x is equal to x will be y fy x is equal to x. Let me just write it. So you know the expectation of y is equal to what? Y fy dy. So similarly, expectation of y given x is equal to x will be is equal to y f of y given x is equal to x d. Okay. So this is what we have written. We have written y and then fy given x is equal to x dy is equal to. Okay. Now we can solve it. This one is, so expectation of y given x is equal to x will be equal to, this is 2y square. So 2 by x is constant, y square will be y cube upon 3, and the limits are 0 to root x. So this one is 0 to x. This one will be x root x divided by 3. In the time of 0, it will be 0. So x will be cancelled out. Ultimately, we will have 2 root x upon 3. That's the answer. Any questions? Or if you think that I just teach so fast, then also you can tell me. What? I teach so fast? So you need to tell me, na? Like, okay. So if you have any doubt, you can just ask me, or then you can tell me that this goes. Um, do you need any break to understand all this, or can I continue? Okay, so I'll continue. Okay. So next question, what we have is that consider two joint density function f1 and f2 corresponding to the random variable x1 y1 x2 y2 as this. So which of the following is true? So basically you have given f1, you have two distributions. So just check with the first one. So you have given one density function, joint density function, and then it is asking that whether uh, x1 and y1, that means whether these variables are independent or not. So independent means in the time of random variable, we have seen that if two variables are independent, then probability of xy is equal to probability of x into probability of y. So in the time of independent, what happens is that probability of xy is probability of x into probability of y. That means basically the intersection. So here, if we have f1 xy y1 and we want to find whether it is x1 and y1 are independent or not. So condition for that will be fx x into, that means if the multiplication of the marginal is equal to joint PDF, then it will be independent. Multiplication of marginal PDFs of x comma y is equal to joint PDF of x comma y. If this happens, then this means these are independent. So all we need to do in this question is that we need to find the joint PDF. We need to find the marginal PDF of x and y. Firstly for f1, and then we will see that x1 and y1 are independent or not, and then we will do the same procedure for the next f2, joint PDF of f2, and then we will see whether these are independent or just add some slides here. Okay. So Firstly, we will have f1 x1 y1, and it is equal to 6 raised to the power minus 2x1 plus 3y1. Limit is x1 y1 is greater than 0, 0. So I will do the marginal of x. The similar will be the marginal of y that you need to do after this. So I'll give you 5 minutes for that, and then we will see whether it is independent or not. So marginal of x will be uh, since the limit is what x1 and y1 are greater than 0. So this is 0 to infinity. It will be 6 e to the power minus 2x1 plus 3y1, and then it is margin of x, so integration will be with respect to y, limits will be of y. So this is limit of y, not of x. Now e to the power minus 2x1 will be the constant one. So we can write it as this 6 e to the power minus 2x1 e to the power minus 3y1, because if e to the power a plus 1 a plus b is e to the power a into e to the power b. Now this one is the constant one, it will come out e to the power minus 2x1, and this one will be the integrated one. So e to the power minus 3y1 integration will be e to the power minus 3y1 divided by minus 3. Now if you don't know how to, like if you don't know the direct formula, you can do 3y1 is equal to t, y1 is equal to t by 3, and then you can solve it. So this will be the same, this will be the answer, 0 to infinity. So now e to the power minus infinity is 0 and e to the power 0 is 1. So it will be 6 e to the power minus 2x1 and then 1 by 3, because when we put 0 it will be minus, so minus minus will be cancelled out. So 3 6 it will be 2 e to the power minus 2x. Okay. So fx x1, this one is 2 e to the power minus 2x. Now f by y1 will be 0 to infinity 6 e to the power minus 2x1 plus 3y1 dx. Can you solve it? I think this one is very easy, and this one is just the same as fx x1. So I'll wait for 5 minutes to solve it. Okay. Is it done? Okay. So whether you have solved or not, just check you did it right or not. So this will be 0 to infinity. This one will be 0. Then e to the power minus 2x1, e to the power minus 3y1 dx. So this and this term are constant and this one is variable right now. You can just put your dx. So it will be e to the power minus 3y1. So for this it will be e to the power minus 2x1 divided by 2 and this one. So, so in the time of infinity it will be 0, in the time of 0 it will be 1. So ultimately you will have 3 e to the power minus 3 by 2. So now fx x1 f by y1 is equal to 2 e to the power minus 2x1 into 3 e to the power minus 3y1. So 2 into 3 will be 6 e to the power minus 2x1 minus 3y1. So this is same as 6 e to the power minus 2x1 plus 3y1. So this one is equal to fxy at x1 y1. So now you have this multiplication of marginal PDF of x. This one is multiplication of marginal PDFs of x. is equal to joint PDF of x1 and y1. So this is what? This one will be the independent. Okay. So x1, y1 are independent. Now we need to check for the second one. Okay. So for the second one is f2 x2 y2 is given as 6xy and then 0 to 1 0 to 1 next 0 to 1 is 6 0 is okay. So now we will do the same procedure for this also. It will be better if you will not just see and look what I'm doing. You also do the things with me on the paper and pen. You know, otherwise you will just listen all these things. You will think that you have understood everything, but when you will go on your own, you will forget because in the time of finding marginal, you will forget that whether to put the limit of y, whether to put the limit of x, and then how to find the expectation and so on. It will all be so difficult if you will not do on your own. So just while I'm writing, just do it on your own and just check. If you need some time to check, just tell me. I'll wait for it. Okay, so firstly, we'll find the marginal of x. So that one will be for the marginal of x, we do the limits of y. 6x to y2 and then integration over y. So this is constant, this is variable. For y2, it is y square upon 2. So this is 6x2 and y square upon 2 will be just x2 upon 2. So it will be 3x2 square. Now fy y2 will be 0 to 1 6x2 y2 dx2. So the variable here is x2. It will be x square upon 2. So it will be just 1 by 2. Right? In the time of 1, it will be 1 by 2. In the time of 0, it will be 0. So this one is 3 by 2. Okay. Now, if you do the multiplication of x2 and y2 marginus, this one was 3x2 square. This one was, sorry, 2 by 1, I think. 2. This one was 3 by 3 by 2. So this one is 9 x2 square by 2. And x2 y2 was 6 by x by 2. So this is not equal to 6x2 y2. So this is not independent. So x2 comma y2 are not independent. So the answer here will be this. Any confusion? Any doubt? So next one we have is that uh, x, y are two discrete random variables with joint PNF, and then we want to find the covariance of x and y. So covariance of x and y is, anybody remember the formula of covariance of x and y in terms of expectation? Okay, so covariance of x comma y is equal to expectation of xy minus expectation of x times expectation of y. So we want to find the expectation of x, expectation of y, expectation of xy. So for expectation of x and expectation of y, we need the marginals of x and y. So we need the marginal of x and then better to write px and then py. So this one is 1 by 2, 1 by 8, then 5 by 8. This one will be 1 by 8, this one will be 2 by 8, so 1 by 4. This one is 1 by 8, this one is 1 by 2, this one is 3 by 8. Now its summation, you can check this. Now to find the expectation of x, can you do that on your own? Expectation of x and y. Okay, it's very easy, but so expectation of x will be what? X fx. So 1, 5 by 8 plus 2, 1 by 8 plus 3, 1 by 4. So just solve it. 5 by 8 plus 1 by 4, 3 by 4 is 1, 5 by 8 plus 1 will be 13, right? Expectation of y is 1, 1 by 8, 2, 1 by 2, 1 by 2, and then 3, 3 by 8. So it will be 8, just 1 plus 8 plus 9. So 9, 1, 10, 18 upon 8, it will be 9 upon 4. Now expectation of xy. Expectation of xy, we find it as uh, summation xy fxy or pxy. Okay. So xy firstly will have 1 and then 0. 1 into 2, 2 into 1 by 2. So it will be 2 into 1 by 2. Then x and y, 1 times 3, 3 into 1 by 8. And then 2 into 1 into 0, 2 into 2 into 0, 2 into 3 into 1 by 8. So 2 into 3 will be 6 into 1 by 8 plus 3 into 1, 3, 1 by 8 plus 3 into 2, 6 into 0, 0, 3 into 3, 9 into 1 by 8. So 9 times 1 by 8. Is it understood or any confusion? Do I need to repeat? Okay. Okay. So this one is just 1 plus 3 by 8 plus, okay, so we can take 8 as common. This one will be 8 plus 3 plus 6 plus 3 plus 9. So integration we have 8. Above we have 3, 3, 6, 6, 6, 12, 12 and 8, 20, and 20 and 9, 29. So it is 29 by 28. Okay. So now covariance is what? Just 29 by 28 minus 13 upon 8 times 9 by 4. Right? So this one is 29 divided by 8 minus 13 divided by 8 into 9 divided by 4. So this one is minus 1 upon 32. Minus 1 divided by 32 is 0.3125. Minus 1 upon 32. So this is the answer. So the next question is that uh, you have a fair die roll n times, and then x and y are the random variable denoting the number of ones and denoting the number of twos. You have given covariance of x y is equal to minus 1 by 4. So now when you have 1 and 2, x and y denotes the number of ones and twos. Then these are independent. When 1 is coming, 2 cannot come. When 2 is coming, 1 cannot come. So you will have this one will be 0 and you will left with expectation of x and y. So that one will happen when it is 1 by 6 and 1 by 6. So basically the covariance of x, y you will have will be this one is 0. So minus n, and in n you will have 1 by 6 and 1 by 6. This one is for x and for y. Okay. So this one will be minus n upon 36, and you have given this one as minus 1 by 4. So this is just cancel out and is equal to this is very basic. So next you have given here is that x and y are bivariate normal distribution with the parameters given. Then we want to find px plus y greater than 0. Okay. So x is normally distributed with 1, 1. Y is normally distributed with 1 and 9. Okay. And then row given here is half. Row is that it's covariance. Okay. So now you will have x plus y. You want to find the probability of x plus y. To do the questions like this, what we take is that now x plus y follows which distribution. So you need to know when x is normal distribution, y is normal distribution, then x plus y is also normal distribution. Now to find its parameters, so firstly what we know is that x plus y will follow normal distribution. Now we want to find the mean and the variance. So mean expectation of x plus y will be expectation of x plus expectation 1. So that one will be 1 plus 1. This will be 2. The variance of x plus y is what? Variance of x plus variance of y plus 2 rho, uh, which is correlation parameter. So you can write just covariance of x plus y. Okay, x y. I'm writing covariance of x y and then I put separate. So covariance of x y divided by sigma x into sigma y is equal to rho. This is correlation parameter. So covariance of xy is not given here. We have given sigma rho. So it will be rho xy. So this term we can write it as 2 rho sigma x into sigma y. This term we can write it as this. So so variance of x plus y will be variance of x is 1, variance of y is 9, and then 2 times rho, rho is 1 by 2, sigma of x is 1 and sigma of y is 3, which is sigma x is what? Variance under root of variance. So this one will be cancelled out, 9 plus 1 10, and then it will be 30. So now we know x plus y follows normal to 30. So now we can find probability of x plus y greater than 0 with the help of standard normal variant. So standard normal variant is what? Variable minus mean of variable whole divided by the standard deviation of that variable. So it will be x plus y, its mean is 2 and sigma is root 13. We'll do this on both the sides. So it will be minus 2 divided by root 13. Now this one is z. So z greater than or equal to minus 2 by root 13. Now you can see z divided by some less than some value will be greater than or equal to this value. So you can find uh, either just you can find it by 1 minus z at root 13, and that will be the answer. So 2 by root 13, you can find that point and then solve. Any problem? Okay. So now we have the next question is that suppose x and y are bivariate normal distribution, and then we want to find such a so that ax plus y and x plus 2y are independent. So two parameters are independent. That means expectation of xy is equal to expectation of x into expectation of y. So expectation of x y is equal to expectation of x into y. That means covariance of x comma y is 0 or correlation. So correlation is 0. That means covariance is also 0. So firstly, we will write x follows normal distribution 0, 1. Y follows normal distribution -1, 4. Row given in here is minus. So you have two variables ax plus y and x plus 2y. We want to find whether these are we want to find such a so that these two are independent. So these two will be independent when the covariance between them is 0. So covariance between ax plus y comma x plus 2y is equal to 0. Okay. So then we can do it in this way. So minus of x plus 2a plus 1. So we can just find expectation of ax plus y, x plus 2y minus expectation of x and expectation of y. Or let me just check if there is any problem. So, this. So I think you can write it separately with covariance of ax plus y comma x plus covariance of ax plus y comma 2y, and then this one also as covariance of ax comma x, covariance of ax comma x plus covariance of y comma x. This one for the first term, and for the second term I think let me use one page. So for this will be plus variance of ax comma 2y plus covariance of y comma 2. So first term and second term can be written as this. Now covariance of ax comma x will be a covariance of x comma x. So when you take covariance with itself, then it will be variance. So it will be a times variance of x plus covariance of x comma y plus this one 2a will come out as constant, and then 2 variance of y. Right? So a times variance of okay. So a times variance of x is 1 plus covariance of xy is what? Rho. sigma of x, sigma of y is minus 1. Okay. Now this one is covariance of xy, this one is covariance of xy, its coefficient is 1, so we can write it as 2a plus 1. And then 2 times variance of y is 4. So this will be equal to 0. So this one is uh, 0 is equal to a plus 8 plus 2a plus 1 times this is minus half, this is half, this one will be 2, this one is sigma x, sigma y, this is 0. So this one will cancel out, it will be minus 1. So you have basically minus 2a plus a minus a plus 8 uh, minus 1, 7 is equal to 0. So a is equal to 7 will be the answer. Is it understood? Okay. Okay. So here it is given that x and y be the bivariate normal. Have you gone through the notes where bivariate normal distributions density function is defined? So no, I will just write. So what is given here is that x comma y being the bivariate normal distribution in its PDF is given. So we want to find the correlation between x and y. So this is basically the thing that you have given the values and you just need to put it and solve it. So the joint PDF is defined as fxy is equal to 1 upon 2 pi sigma x sigma y under root 1 minus rho square. Okay, expectation minus 1 upon 2 1 minus rho square and then x minus mu x whole square divided by sigma x square plus y minus mu y whole square divided by sigma y square minus 2 sigma rho x, oh sorry, sigma x sigma y x minus mu x y minus mu y. So this is how we define bivariate normal distribution. So if x and y, let's just say x and y are independent. So in the time of independent, this row will be 0. So you will have 1 upon 2 uh, 1 upon 2 pi till sigma x, because for the first one it will be 1 upon root 2 pi sigma x. So in the time of multiplication, 1 upon 2 pi sigma x sigma y. If rho is 0, and then expectation, this will not come, this one and this one. So in the time of x and y, when they are not independent, when they are correlated, so this is the formula. I don't know where in there is proof or not given, proof is given or not, but you can check. So now all we need to do is that we need to see this expression. We need to just compare this expression by this expression to find the correlation. What is correlation? Correlation is row. To find, so we want to find the row. Now to find the row, firstly we can do like 1 upon 2 pi, 1 upon 2 pi same, and then here is row. So we can see 1 minus rho square sigma x sigma y is equal to what? Root 3. Okay. So we can write sigma x sigma y 1 upon rho square is equal to root 3. Now we can take a similar expression, like we can compare it with this also, this also, this also. So here it is given x minus mu x minus 1, y plus 1. So mu x will be most probably 1, this one will be minus 1. So this expression will be is equal to what? Minus 2 by 3 into minus half. So minus 2 by 3 into minus half. Just see the coefficient. Okay, so the coefficient of x minus mu x and y minus mu y, x minus mu x and y minus mu y is what? Minus 2 by 3 minus half. Here the coefficient of x minus mu x, y minus mu y is what? Minus 1 upon 2 by 1 upon 2 1 minus rho square and into minus 2 rho divided by sigma x sigma y, right? So this one will be plus plus is equal to this. Now from here we can take the value of sigma x sigma y. So if we will put it in this expression, we will left with the one variable, that is rho, that we want to find. So that one will be from these two. If we put the value of sigma x sigma y here, rho square, and then this one is 2 rho, and then sigma x sigma y is what? Root 3 divided by root 1 minus rho square, and then this will be 1 by 3. Now this one will cancel out with this one will be 1 minus rho square, this one will cancel out, and then we can do the square because there are too many roots. So in the time of square, upper it will be rho square, lower we will have 3. This is root, so root will not come, is equal to 1 by 9, right? We will do the square on both sides. So 3 will be cancelled out. So ultimately it will have 3 rho square is equal to 1 minus rho square. So it will be 4 rho square is equal to 1. That means rho square is equal to 1 by 2. So rho can be plus minus 1 by 2. So it will be 0.5. Okay. So, next question is this. Next question is similar to the previous one. All we need to do is that just compare it. This one is given, just compare it, and then when you compare, you can find the values. So, this you can directly see that this one, this one, this one. So, mu x will be what? 2, mu y will be 1. Okay, so this is given all. So, now variance of x and then variance of y. May, main thing is that row you need to find, and then you can solve it as you we have done this question. This is this the copied one. Now the next question we have here is that x and y be two continuous random variable, and the joint density is given here, and then we did the similar question like this. I think here, right? So fxy was given, and then we want to find what is probability of y less than x. I'm solving it, but you just do it with yourself also to see whether you have understood or not. So fxy region is given. It is in between 0 to 1, right? So x is 0 to 1, y is 0 to 1. This one is the whole region. And then uh, we want to find the probability when y is less than x. So y is less than x in this portion. This is the line of y is equal to x. So again, we can do it with the x first and then y second, or y first and x second. Doesn't matter. Okay. Yeah, yeah. ओके ओके तो देखो फर्स्टली क्या करना है कि you need to see where fxy is defined. Okay, so firstly fxy is defined in this region. So firstly draw the line and draw where x and y is defined. So x is in between 0 to 1, y is in between 0 to 1. Okay, so this one will be the region. Just draw this lines. This one is the region where fxy is defined. So x is in between 0 to 1, y is in between 0 to 1. This is the region where fxy is defined, and otherwise in this region, everywhere fxy is 0. Now we want to find y less than x. Probability when y less than x. So you have anything given here, any inequality given here, you just need to consider it as equation firstly. Okay, to make the line. So let's just see y is equal to x. Now y is equal to x is what? When y is equal to x, so angle, and then is still if you have any confusion, then you can just take it as x minus y is equal to 0, and then intercept will be 0 and 0, so this line will pass through 0, that is obvious. When x is equal to 1, if you have so much of confusion, you can try by taking the points. So when x is equal to 1, y is equal to 1. So when x is equal to 1, y is equal to 1. When x is equal to 2, y is equal to 3. Sorry, y is equal to 2. When x is equal to half, y is equal to half. When x is equal to 1 by 3. So you can just make some points, and then it will be visible to you what is the line. This one is very simple. Otherwise, if you have line equation, the best thing I told you is do the intercept form. Otherwise, you can draw like this. Now this line is y is equal to x, right? So this, and then we want to find the region where y is less than x. So y is less than x. So you can just check this one is the region where y is greater than x. This one is the region where y is less than x. But still, if you have any confusion, you can again do the points things, right? So you can just see here. Here x is somewhere less than just 1 and y is near 0. Okay. So y is maybe 0.1 or 0.2 and x is here 0.8 or something. So x is greater here. Now if you take any point here, x will be y will be greater than x. So that there's this way you can see, like if you draw it multiple times, it will be understood. But otherwise you can, it's best way to check with the points whether the thing you are seeing, whether it is right or not. So now you have seen that x, this is the region where y is less than x. So this will be the region where we want to find the probability. Is it understood me? Okay. Okay. Now you go through different kind of lines. Like let's say x plus y is, mm see, the maximum x plus y can be 2. So then you can find that line, and then maybe x plus y less than half. So if we want to find x plus y, is it less than half? Let's say we want to do this, or greater than, let's say less than we did, so greater than. So firstly what we will do, we will convert this inequality into the equation. So it will be x plus y is equal to half. Now the best way is intercept. Intercept will be this. Okay. So make it 1 here and make it intercept here. If there is any negative, make it like minus here. So 1, 1. So at half, half will be somewhere here, half will be somewhere. Let me try this. Okay. This is the place where the region is defined, and half and half. Okay. Let's say this one is half, this one is half, this one is 1, this one is 1. And then we want to find x plus y greater than half. So greater than half will be the upper portion. So this is the region where x plus y is greater than half. Okay. So now you can just do it with the multiple points and then you will understand. Oh, it's just so here we want to find the probability of y less than x. So that will be fx. So the region will be, firstly it will be for let's say x, I'm taking it as 0 to 1, and for y, uh, the below one is that y is equal to x, and above portion is y is equal to 1, right? So just consider it as this. So in the x is 0 to 1, and y is in the bottom line, y is equal to x. In the upper one, it is y is equal to 1. Okay. Now if you do this by limit of x, firstly, so it will be x, let's say. So x is will be 0, and then x is equal to y, and then for y it will be 0 to 1. Y is changing from 0 to 1. Okay. Okay, so we can do it by this way because there is 0, so less limit thing. So then x plus y, and we are taking the limit of x firstly. So we will differentiate with x firstly, and then we will differentiate with y. So it will be 0 to 1, and then x is the variable, y is the constant. So it will be x square upon 2 plus yx dy, and the limit will be from 0 to y, right? So this one will be 0 to 1. X square upon 2 will be y square upon 2 plus y square dy. So it is 3y square upon 2. So 3 by 2 will come out. Y square will be y cube upon 3. This one will be 0 to 1. So 3 by 2 times 1 by 3, 1 by 3, 1 by 3 will be cancelled out. 1 by 2 will be the answer. Okay. Now next question we have very similar, and then just see the region 0 to 1, 0 to 1. So this one will be the region where PDF is defined, and we want to find the probability x plus y less than k, 0 to k 1. Okay, so this will be k, right? Because k is less than 1. So let's say this is somewhere here, and then x plus y less than k. First thing is to convert into the equation x plus y is equal to k. Next thing is to find the intercept form, and then draw the line. So k and k intercept, draw the line, and then less than k will be the lower portion. So this is the region where we want to find. Okay. So uh, y, now you can take any firstly. So first one will be 0 to k. Let's say x is from 0 to k and y is from, this is the line y is equal to 0, and this is the line x plus y is equal to k, right? So y will be k minus x. So this is the line k minus x, and then this is 1. We firstly differentiate with y, so it will be dy. Okay, so this is constant, y will come. So in the time of y, it will be k minus x, right? Dx. Now it will be kx minus x square upon 2. You can just put k here. So it will be k square minus k square upon 2. So it will be k square upon 2. So k square upon 2 will be the answer. Okay. Now, um, so again we have the similar question. We just have uh, this less than m, x plus y is less than m, is equal to 1 by 2, then the value of m will lie between. So x is greater than 0 and y is greater than 0. So this is the whole region, like this. All this will come under fxy. Given here is that x plus y less than m. So Similarly, x plus y less than k. So then we can find this line. Okay, and its probability is 1 by 2. Okay, so then we want to find the value of m lies in between. So what we will do is that we will just check. Okay, so okay, this is the region, and then you need to differentiate here. So x limit will be 0 to m, y limit will be 0 to m minus x e to the power minus x plus y dy dx. So in the time of y, e to the power minus x is constant, so that one will come out, right? So 0 to m e to the power minus x will come out. The integration of e to the power minus y will be e to the power minus y divided by minus 1, 0 to m minus x, right? Dx. So it will be 0 to m e to the power minus x e to the power minus m plus x. This minus, just write it here. And this one is e to the power minus 0, which one is 1. Now we will multiply it e to the power minus x e to the power minus m plus x. So x will cancel out. It will be e to the power minus m. So 0 to m e to the power minus m minus e to the power minus x dx. Now this term is constant, so just x will come. So it will be minus e to the power minus m times x minus e to the power minus x divided by minus 1 will be 0 to m. Now we can put the limit. It will be e to the power minus m times m minus e to the power plus minus minus will be plus, right? E to the power minus m minus e to the power this will be 1, right? So given here it is 1 by 2. So now this one is plus 1, it will go here, or these things are negative, so we can just write e to the power minus m plus 1 is equal to 1 minus half, that will be half. Okay, now you need to check what is the value when we put m is equal to 0. So m is equal to 0 is uh, e to the power 0, which will be 1, and then this will be 1 plus 1, sorry, 1 plus 0 will be 1. So this one is 1, and uh, at 1 at 1 it will be m plus 1 will be what? 2 divided by, so at 0 its value is 1, at 1 its value is 0.73. So now 1 by 2 is not in between 1 and 0.73 and 1. So this will not come. Now you check for 2. Okay. So at 2 We are just finding the values of this function at 0, at 1, at 2, so that we can find at which range this m is lying. So for 2, it will be 3 by e square, so it will be 0.4. Let me just make one table. So at 0, 1, 2, 2, 3, and 4. At 0, this one is 0. At 1, it is 0.73. It is 0.4, 1. And at 3, it will be 4 divided by q, which is 0.19. And so it is basically decreasing. So this is the range where the value is half will come. Okay. So m ranges will be in between 1 and 2. So this one will be the answer. Is it okay? Any doubts? Any doubts here? Oh no. Okay, great. So next question we have here is that fxy is given, and then all we want to find is that variance of x plus y. So region, x and y this. So to find the variance of x plus y, we need to find the expectation of x plus y firstly. So x plus y will be what? 0 to 1, 0 to 1, x plus y. Okay, and then this one is x plus y from here, and then we will have fxy. So x plus y, this is also x. So you will have 0 to 1, 0 to 1, x plus y whole square dx dy, right? So now you can do it in uh, y firstly or x firstly. So I'm doing it as y firstly. So now if you have a plus x, then its integration will be a plus x square by 2, because this time this is just a constant. I think now you put the value, it will be 0 to 1. Okay, this one will be uh, x plus 1 cube divided by 3 minus, and the time of 0, it will be x cube divided by 3 dx. Okay, so this one will be so okay, I need to do that again. So x plus 1 cube will be x 1 by 3 will come out. Okay, so for x plus 1 cube, it will be x plus 1 to the power 4 divided by 4 minus x to the power 4 divided by 4, ranges from 0 to 1. So 1 by 3, when we put 1, it will be 2 to the power, take 4 also, come out. Okay, and when we will put 0, it will be 0 plus 1 to the power 4, so basically 1. Similarly, here also it will be 1. So it will be 2 to the power 4 minus 2. So 2 to the power 4 is what? 16. 16 minus 2 will be 14. 14 upon 12 will be 7 upon 6. So this is expectation of x plus y. Now to find the variance of x plus y, it is expectation of x plus y whole square minus expectation of x plus y. This one's whole square, right? So next thing we want to find is expectation of x plus y square, which will be 0 to 1, 0 to 1, x plus y. Now x plus y whole square will come here, and then x plus y is fxy. So this one will be whole cube dx dy. Now again we do the same integration now. So it will be x plus y to the power 4 upon 4 limits of y dx. So 1 will be x plus 1 to the power 4 upon 4 minus x to the power 4 upon 4 dx. Right? Now 1 upon 4 will come out. X plus 1 to the power 5 upon 5 minus x to the power 5 upon 5. Limit from 0 to 1. 1 upon 20. It will be 2 to the power 5 minus in the time of 1, sorry 0, it will be 0 plus 1 to the power 5 will be 1, 1. So 2 to the power 5 is I think 32. So 32 minus 2 is 30. 3 by 2. So variance of x plus y will be 3 by 2 minus 7 by 6 whole square will be 3 by 2, 49 by 36. So 36, 18, 54, 49, 25 by 36. So 5 by 36 will be the answer. Okay. Is it okay? Any doubts? Any confusion? Okay, so stopping the meeting, and then thank you for the joining. And the next class you have on Friday because the last Tuesday class I have not taken. Okay, so meet you there. Thank you. Bye.